Okay, now let's have a look at some other examples. Let's look at this question. So we have 3x squared plus 5x over 2x, and what we want to do is we want to differentiate this function. So if you think about the rules that we know already, they were y is equal to kx to n, which was y dash is equal to kn xn minus 1. And if I had just yx to the n, it would just be y dash is equal to nx n minus 1. Remember that there's actually no difference between these two. This formula is a specific version of this more general formula. In this one, the only difference is that your k value is 1, and that's why we don't write it. So you can just go ahead with only this formula. So long as you remember that, you basically know this one as well. Okay, so we've known these formulas so far, and we also know that if we have two functions being added together or subtracted from each other, you can basically say the y dash or the gradient of this function is just differentiating each of these functions individually. But you can see that none of these formulas that we've looked at so far can deal with division. So what we need to do is we need to solve that problem. So I'll just write that down again. Now, what you need to think of is if I had 1 plus 2 over 3. Okay, so just a simple fraction. What I can do is I can write that as 1 over 3 plus 2 over 3. So each of these terms that are being added in the numerator can be written separately on top of the denominator, and this is basically the same as that. So we can do exactly the same thing here. So we can write the first term over the denominator plus the second term over the denominator. And now what I can do is I can simplify these as much as possible. So here I can see that I can cancel this power of 2 with one of these x's, and these two x's cancel out with each other. So I'll be left with 3x over 2 plus 5 over 2. Okay. Now here, again, what we know is if I have a times b over c, so this is a general formula, if I have such thing, I can write that as a over c times b, or I can write it a times b or c, b over c, there's no difference. And the general formula for that is just if I have a plus b over c, that's just a over c plus b over c. Okay, so using this, we can just write this as a coefficient. So that's 3 over 2 times x plus 5 over 2. All right, now this is just a simple equation. So I can just say here, I can think of this formula. Now again, n instead of being like 2 or 3, it's just 1. So I just write down my coefficient. I multiply it by 1, bring down my power reduced by 1. So you can think of this as two things. One, you can think of it in terms of this, which means if you want to differentiate it, you multiply your coefficient by your power, which is 1, so you bring down the power, and then you reduce the power by 1. So that's basically x to the power of 0, which is 1. So you're just left with 3 over 2. The other way, maybe more simpler way, is to just think about 3 over 2x as just a linear equation. And we've seen before that if I have something in terms of mx plus b, which is the equation of a line, its y dash is just this gradient. So it's just that. So this simplifies to 3 over 2. And then we also know that if I have 5 over 2, that's just a constant, and the gradient of a constant is 0. So basically your y dash graph is just, sorry, that's still y, so this is still y, and then here you start differentiating, and so your y dash is just 3 over 2. Okay.